Well, hello everyone, and thanks for coming out on a lovely rainy day like today. I'm sure you could all be doing something nice and warm and dry, but great to see you all here. So what we're going to do, let me first just say it's great to have both Andrea and Reem here as part of this event. They both were on the BBC programme with me that came out 2-3 years ago now called Science and Islam, where we talked about some of this history. And also, before I forget, at the end of the film you saw one of the boys, just before he left, he picked up a book, which is called 1001 Inventions, which is actually on sale next door in the Waterstones tent. So after this talk, if you want to go next door, you can pick up your copy, obviously after you've bought a copy of my own book, which I will be signing. So if you need change
commission for both.
Mine's cheaper, but that's prettier. Okay, so you saw the film and you've heard a little bit about this golden age of science 1,000 years ago that a lot of people don't know much about. And apart from what you saw on the film, there were also other great advances in other areas of science, like astronomy and philosophy and medicine and physics. In mathematics, the word algebra, we may not like algebra, well I do, but not everyone likes algebra, but the word algebra comes from the Arabic, al-Jabr, which was the title of a book, the very first book on algebra written in the 9th century. But this year is International Year of Chemistry. So we want to say something about what advances in chemistry were made during this period. So let me briefly say that sort of before the Islamic Empire began, the great civilization many hundreds of years earlier was that of the ancient Greeks. Now, everyone at school, when you do chemistry, you learn about the periodic table and all the different elements that make up our world. The ancient Greeks believed there were just 4 elements: fire, earth, water, and air. And I think that's all they thought. Everything in the world was made out of those 4 elements, and they were connected together by the properties of hotness, dryness, coldness, or wetness, and that was it. It was all very, very simple. But chemistry, as a subject, a lot of people think chemistry didn't really start until a few hundred years ago in Europe, because going back far enough into the dim, distant past, it wasn't really called chemistry. People refer to it as alchemy. Now, alchemy is not like a real science. It's to do with magic and mysticism. In fact, alchemy, the word, comes from the Arabic, alchemia, which is Arabic for chemistry. So alchemy and chemistry were the same thing. Some of it was mixed up with mysticism. Some of it, as we'll talk a little bit about in a moment, was doing proper science. But at its heart, the reason for doing alchemy was to do something special, to turn what are called base metals, boring metals like iron and copper, into precious metals like gold and silver. This was called transmutation. Andrea, don't let me down. Andrea is going to transmute something into gold, right?
I need a rich volunteer. You're a rich volunteer? How rich are you? Have you got 2p? Okay, you don't. Okay, well maybe you should touch someone up to get 2p, like your dad. And what I'm going to do is I'm going to try and see if I can make you rich. Rich beyond your wildest dreams.
He sounds like Ben Kingsley, doesn't he?
Hey, I think you should give it to your daughter. And let's come on stage. What's your name? Noor. Excellent. Noor, of course, means...
Well done, Noor.
Means light, doesn't it? Now, what you're going to do is you're going to give me your 2p piece. And I think we should switch here to my little webcam, if that's possible. This stuff is still hissing away rather nastily, so I'll just put it over here near you guys. If it catches fire, it's not my problem. And what we've been doing is we've been warming up this solution here, and we're going to warm it up. And what I need you to do is perhaps to wear these little safety glasses here. Whoops, no, the hair's in the way. Okay, so we'll wear those. And we're going to take your 2p coin, and we're going to take it with some tweezers. And what we're going to do is we're going to heat it up here in this liquid. And we're going to leave it there for a moment as the liquid warms up gradually. Now, in here, we have a certain amount of mysterious ingredients. And one of the ingredients is an extremely important one that was discovered by sort of Middle Eastern, let's call them chemists. And that was actually, the word is alkali. And it is really what you get when you wash ashes. When you wash ashes, what you find, if you ever try this after having a barbecue, where you've used wood, if you actually pass that through a coffee filter, what comes through will feel very soapy. And in fact, that was the basis of the making of soap. And we're warming up our penny here in the alkali, and we also have a second magic ingredient that we're going to talk about in a little bit. So what we've got here, we're warming it up, and gradually our penny is changing color. The penny is actually fading, and I'm really trying to get my solution here to the boil. And as it gets hotter, can you actually see it? Maybe you can look on the monitor there, and you can see it a little bit more closely.
You see it's turning into gold.
And it's actually fading in color. So, I don't know whether you can see that my penny is actually no longer that rich, deep copper color, but is actually fading gradually. And the more it fades, in fact, I think I might give it a little bit more of that metal, a little bit more of that zinc. As we heat it up, it's going to fade. And what we're doing is something which appears rather magical. We're taking our copper coin and we're gradually making it ever more silvery. And I think this may take 2 or 3 more minutes. We're being a bit slow today.
Okay, well now, I want to focus on 2 characters, 2 famous scientists who really can be regarded as the fathers of chemistry. The first guy is a man called Jabir ibn Hayyan, Jabir, son of Hayyan. He was born in a town in what is today Iraq, in a town called Kufa, which happens to be the same town that my father was born in. So I'm quite proud of this chap. He wrote a lot of books about alchemy and actually some interesting stuff that we might think of as the birth of chemistry. But his life is shrouded in mystery. First of all, he had lots of disciples and supporters who tried to keep all his stuff secret, because if you can make gold, you don't want to tell the rest of the world how you do it. So it's all rather secret. Then there were lots of other people who wanted to get famous, even hundreds of years after him. So they would write books and pretend those books were written by him, so that everyone else would read them because he was so famous. But still, even the text that he wrote, a lot of people couldn't understand. The English word gibberish, which means nonsense, actually originates from gibber, which is what they used to call Jabir, because his work was so complicated, it seemed like nonsense. Now, so he lived in the 8th century. He was one of the very, very first scientists in the Islamic Empire. Not one of the first scientists of all time. There were great scientists in ancient Greece. But I'm calling him a scientist. He was doing lots of magical, mystical stuff. Was he doing real science? So I think I need Andrea to convince us some of the things that Jabir got up to.
Well, one of the things that Jabir was interested in was this issue of transmutation, which hasn't quite worked yet, but we're slowly getting there. And that is the idea that you might be able to transform one thing into another. And this is central to the idea of chemistry. And it's one of the reasons why this alchemy process was considered to be, in a way, a sacred art. It was an art which was at the intersection of a whole series of trades, whether it be the making of pottery, metallurgy, and of course the making of weapons and tools, the making of glazes and colors, the dye processes. All of these were ones which essentially transformed things. And what the alchemists were really doing was trying to get at the heart of what was going on. And one of the things that Jabir thought up was the idea that metals, because you could transform them in such interesting ways, you could heat them and melt them and shape them. In some cases, you could change their colors and so on, was that actually they were all made of the same stuff. And so he actually stepped forward from some of those Greek ideas about earth, fire, air, and water. And he came up with a theory, which was that metals were essentially composed of two major components. One was sulfur, and sulfur was the material which probably best embodied fire. Sulfur burns very, very effectively. It is often found in association with volcanic locations on the Earth. And the second was the most magical material of all, the strangest one, and that is mercury. And I think what I might do is just get a volunteer. I need a volunteer who is not too small. I think you will probably do, because I have here a liter of mercury. And have a look. You can see that it shakes around. I need you up here at the front. And what I'm going to do is I'm going to hand you a liter of mercury. You ready? Okay? Go. Now, we did not plan this in advance. There was no rehearsal. What do you think?
It's really heavy.
It's really heavy. Yeah, absolutely. Thank you very much. So, mercury is this extraordinary, strange substance. Because, first of all, it's clearly a metal because it's reflective. And yet, on the other hand, what it does is, I mean, it's amazingly heavy. And you can heat it up with sulfur. And you obtain this material here. Now, nowadays, we call it vermilion. But what's interesting is that this material here, you can dig out of the ground, and it's called cinnabar. And when you heat this up, guess what? You get mercury, and you get the smell of burning sulfur. And the smell of sulfur was something that often came from smelting, from places where they were smelting metals. Whether you smelted copper or zinc or iron and so on, it was usually a smell of sulfur associated with it. And so there came this incredible sort of idea. Now, we're talking about transmutation. This is now boiling like crazy. And I think, Noor, I could really do with you here at the front again, because I want you to look at this penny. And this is now, I'm going to put this, ooh, it's hot, and it's alkaline. Okay, let's rinse our hands. What do you think of this penny? What's happened to it?
It's gone silver.
It's gone silvery. It's astonishing. And let's just put it here in front of the camera, and I don't know if we have the lights up as much as we can. You may be able to see that at least on this side, right, it's gone a very nice silvery color. You can tell this is a slight, notice the other side is kind of orange. Can you actually see this? You can't see this because I'm holding it wrong. Okay, there's the penny. You look on this side, and it's actually gone a beautiful silvery color. And for comparison, it may be that I'm rich enough to have 2p. Let me just see whether we can, here's a penny anyway, so that you can compare the copper color. But that one is clearly reddish there if I move into the shade, whereas this one is very silvery. And so we have this idea that you might be able to transform metals from one form to another. And in some way, that must be changing the amount of sulfur and, on the other hand, the mercury. Okay, now what I'm going to do is I'm now going to heat this. I'm going to apply that other crucial element. And you know what? I can't get my burner out of the way, so let's get this burner going. Okay? And I'm going to place my silvery penny in the fire. I'm going to give it a little help. Are we on? Why aren't you lighting? Hello, there we go. We're going to heat it up. I'm going to heat it up in the fire. And in a moment, I'm going to ask you to look at the color of it. Now, part of it is slightly blackened. Yeah, sorry, as usual, I'm doing this in the wrong place. We're heating it up. But I want you to look at the color on the front. Can we have the lights right up again now? Just cool it down and quench it in water. And what color do you think it's gone? You noticed how it's changed again. That was the copper color originally.
It's gone kind of goldy.
It's gone kind of goldy. That's exactly it. And so what we've managed to do is to do this extraordinary process, which became known as transmutation, changing the form of things. And we have a material, I have a gold sovereign here, and the two really look fairly similar. This one's perhaps a little bit more goldy than that one. I probably could have done the trick better. Okay, we'll put it on the camera. You guys all want to see the gold, don't you?
Thank you, Judy.
Yeah, the value of gold has gone up, so I've got to be careful and keep you away. But what we've done is transmuted it. And so now we have turned your penny first to silver and then to gold. So thank you very much, Noor.
Thank you very much. Well done, Noor. Now, of course, you know that isn't real gold. It's a coating, it's a layer on the coin that is not made of real gold. In fact,
what we've done is we've made an alloy. What I've done is, in the first instance, I used the zinc to form a layer of zinc on the outside of the copper coin. And you may think that's a bit of a cheat, but I don't know whether you've ever looked closely at pennies. And if you look closely at pennies, it turns out you can pick some of them up with a magnet, and some you can't. And you'll say, hey, wait a second, what's the difference? I got some magnets here. You can see these two 2p pieces can get picked up by the magnets, the other can't. Well, you know what? Modern pennies and 2p pieces are actually made of steel, not of copper, and they've got the coating of the copper on the outside. So in fact, the Bank of England cheats in exactly the same way as the alchemists used to, by making these sort of two material things. And then, so we put the coating of zinc on the outside. And then when I heated, of course, heating, it allows the atoms to move. And the zinc starts to move into the copper. And what you get is the alloy known as brass. Now, they had no real scheme for understanding how these processes were. And the best they could work with were the ideas of, first of all, the four elements from the Greeks, and then this actually rather more sophisticated idea that you might have different amounts of sulfur and mercury, and that what you were doing was actually shifting those by using the fire. And so what you could do was transform one into the other. We know that can't be done now, but actually it was a pretty smart observational theory of the time.
but was this real chemistry? They thought they were transforming, or they're trying to find a way of transforming base metals into gold. Is this what we'd call proper science? Also, a lot of the names that we still use in chemistry today, alkali, alcohol, they all derive from the Arabic. But just because a name for something derives from that language, does that mean they invented a science? Well, certainly people like Jaber were the first to actually do very careful experiments, proper scientific experiments, weighing materials in very careful quantities, mixing them together and recording what they get. They may not have had an exact idea about atoms and about all the elements of the modern periodic table, but they started to do proper chemistry. Now, the second person I want to very briefly introduce was a man who lived over a century after Jaber, and his name was Ibn Zakaria al-Razi. He was a Persian, so Persians refer to him as Razi. He was so famous that Europeans derived a Latin name for him, Rhazes. He went beyond what Jaber did. He was the first person to really start to go beyond this idea of the Greeks' four elements or this sulfur-mercury theory and properly try and classify different types of materials. Now, Andrea, you've brought along maybe a selection of the sorts of classification scheme that he came up with.
So what I have here is now a huge mess of different materials. But what Rhazes did was to begin to say, well, look, actually the world is made up of different kinds of materials, and we can classify things. And the first of these were what he called the spirits. And the spirits were essentially materials that you could volatilize, that were volatile, that would fly. If you heated them up, you could boil them, and you could do, if you will, distillations. And they distilled using devices that became known as alembics, in which essentially you heat on this side, and the vapor rises and then comes down this tube, it cools, and then comes out the other end. And amongst these were mercury, which could be distilled at your peril, but of course they weren't quite so aware of that then. Sulfur, which would melt and become volatile. And also, as we've seen, this sal ammoniac. Now, other materials that they were aware of. There were also what were called the seven bodies, and these were the seven metals. And so here we have copper. We've already seen my gold sovereign, which has disappeared somewhere. We've mentioned zinc. we've mentioned tin, we have lead. And these are the ones which, in fact, were known in antiquity. These elements had been known for a very long time. There were then salts. And this classification includes a whole series of what nowadays we think, well, he kind of got it wrong. But he had a black salt and a white salt and various colors of salts. But remember, they didn't have very many tools to sort of identify things. And so if two salts, for example, tasted different, you might have bitter salt and you might have black salt. But that was simply because of contaminants. But salt, of course, ordinary sodium chloride, was in the classification. And then there was a crucial set of substances. And these are what we now call the sulfates, but they called them the vitriols or marcasites. And I have here blue vitriol, copper sulfate. This is a crystal I've grown, or a series of crystals I've grown with an architect friend of mine. And if we can have this, the camera
please.
You can see here this enormous sort of brain-like copper sulfate agglomeration. And the other one, which is ferrous sulfate, and this is green vitriol. And the name vitriol actually comes from the Latin word for glass, and you can see that it's got that kind of glassy green color. And the crucial thing about these was, first of all, they turned out to be associated with metals. You got them from around the periphery of metal mines, and so they seemed to be connected to them. But most importantly, they could be used to transform things. And I think we're running out of time a little bit, but one of the things that these vitriols or marcasites allowed people to do was to make acids. One of the tremendous concepts in alchemy, which of course remains with us today, is the idea of the solvent. The idea that you might have a material which could dissolve something else. And dissolving was something, it looked as if the liquid part was actually eating the solid. And if you put some sugar in with some water and you stir it, where does the sugar go? It looks as if the liquid is eating it away. Now, it was known that mercury was the solvent for gold. If I drop my sovereign in there, it will disappear and spread out inside. Well, solvents were interesting, and it turns out that acids could actually eat metals. And the way in which they obtained acids was by heating these marcasite vitriol materials with a little bit of water, and what they could do was then distill out acids. When did this happen? There's a lot of argument in the literature. There are books that are attributed to Jabir, which suggests that he was making acids. But there's one other important thing that you need to know about alchemy versus modern science. And the movie, I think, illustrated that very, very well. And it's something which remains with us today. This idea that there was lost knowledge in the past, that the Greeks, that the Romans, they knew all the stuff, and then in the Dark Ages we forgot it all. And the alchemists lived with that kind of view, that somewhere in the dim and distant past people had known how to transform things, and now they'd forgotten and they were desperately trying to come back and find stuff. And so to give any textbook or work, scholarly work, authenticity, what they would do was not write under their own name, but write under a pseudonym. And so there are a whole series of books which are said to be by Jabir, but which almost certainly were written 300 years later. And so the discovery of acids, which comes from these two materials, copper sulfate and iron sulfate, the vitriols, seems to come a little bit later. But acids allow you to dissolve metals, and then really stuff starts to happen. Jim.
Well, I just want to end by just reminding you of how far we've come since those early days of classifying the elements. So people like Jabir and Razi, they were trying to divide up the world into all the stuff that things were made of, the building blocks of all the materials. So when they came up with acids, they weren't aware that an acid was made up of different elements. We now know, and we're now familiar with the modern periodic table of the elements. I just want to end by showing you that even this table is not something that's done and dusted. We haven't got to the end of the line. We haven't now figured out the whole of chemistry and can sit back and not do any more. Because you learn at school that there are 92 naturally occurring elements, 92 elements in the periodic table. And I don't want to get too technical about it, but actually there's a lot more than that. And there are elements that we can now make. We can make new atoms of new kinds of elements. So if you'll see down the bottom of that large chunk at the end, there are elements that are just have a number. They're what's called their atomic number. We're now naming these elements, so some of them, number 110 has the wonderfully simple name Darmstadtium. That's what it's called. So you have about hydrogen, helium, and lithium, and carbon, and oxygen, nitrogen, all the way up to Darmstadtium. Well, Darmstadt was a town in central Germany where there's a big research laboratory where they first made this new element. There's also element 111 is called Rontgenium, named after Röntgen, the man who discovered X-rays. Element 112 is called Copernicium, named after the great astronomer Copernicus. And I don't know if many of you were aware, but a few days ago there was some news about 2 more elements that have been discovered, that have been confirmed, and they're elements 114 and 116. They don't have names yet, but they were discovered in Russia in a laboratory just outside Moscow, and so the 2 names that the Russians are pushing for them are flerovium, named after the chemist George Flerov, who was the leader of the experiment that discovered them, and moscovium, after the city of Moscow. And believe me, there's a huge debate that's going to go on over the next 2-3 years probably before the world scientific community of chemists can come to an agreement about what to call it. Because every country that has a laboratory that makes even a single atom of a new element will then argue they want to name that element after one of their famous scientists or famous cities and so on. It's great fun. But chemistry is still a living, growing subject. And you can trace back, of course, the origins of the elements back to the 4 elements of the ancient Greeks. But earth, air, fire, and water is a bit silly. Those are not fundamental elements. We really do see the birth of what we call chemistry back during the time of these medieval alchemists like Jaber and Razi. I think we should stop there and give you a chance to ask us a few questions, and then we'll so we can sort of finish on time. So thank you very much for listening. We'll have the lights up now. We have roving. Go on, clap for us, because we deserve it. Thank you very much.
I'd like to ask if you've identified or made element 114 and 116, does it make it easier to identify 115?
Do you want to deal with that, Andrea, or shall I?
And the interesting thing is, I mean, it gets very tribal. I mean, these are experiments which are done in a way that are really quite alien to the chemist. In what you're doing is not really, the chemists work with the electrons around the outside, and what these guys are doing is they're really smacking together nuclei to fuse together to make new elements. The real challenge lies in knowing what you have. How do you identify the unique signature associated with that? And that really requires a huge amount of theoretical, computational type chemistry, physics, the kind of stuff that Jim really does. And you only have, at a time, in some cases, 1 atom. Now, when I hold up this thing, we have 10 to the power 21, 22 atoms, molecules in there. These are incredibly difficult experiments, and each one of these elements has a completely unique signature. So the answer is no. Element 115 is not kind of an average between 114 and 116. It's got its own personality, just in the same way as sulfur, for example, is not really an average of chlorine to its right, and phosphorus to its left.
And it is easier to make the atoms with even numbers, atomic number that's an even number, because the way I should say my T-shirt says to do nuclear physics or not to do nuclear physics. What a stupid question. Of course, you should do nuclear physics, and a lot of the new elements, as Andrea says, discovered by nuclear chemists and nuclear physicists because they're making single atoms. And these 114, 116, the way you know they're there is because they don't hang around for very long, just a few seconds usually, maybe even less than that. So what you do is watch what happens to them when they radioactively decay, and they spit out things like alpha particles. And you have these detectors that capture the alpha particles, like Geiger counters inside these accelerators, and see what happens to this element afterwards. And it's much more easy for an element like 114, 116, 118 to spit out an alpha particle than it is for one with odd numbers like 115. That's why you often see gaps in the table. But it'll come.
How old were you when you got interested in science?
Very good question.
Well,
Very good question.
we were both 23, 24 years old at the moment, so a few years ago.
Yeah, I'm pretty old. I think I always kind of knew that I wanted to be a scientist. I kind of knew from a very, very early age that that's what I wanted to do. And funnily enough, about 2 years ago, somebody sent me one of the most embarrassing things I have ever been sent. As a child growing up in New York City, I'm not American, but I lived in the States, I was invited onto a very famous television show with children from my school. And at the very back of the group of children in this thing, she sent me the video clip from this television thing. And at the back, there is a very geeky child who sits there and who fidgets all the way through. And that may seem familiar. And I was asked only one question, that is, what do you want to be when you want to grow up? And I said I wanted to be a scientist. And so, pathetically, I have been trying. When I was at university, I tried to study Russian and economics and art history, and I just kept getting pulled back in to science. I've always kind of been into it, and so yeah, for as long as I can remember. And so maybe if you love it now, there's a chance that you will love it and be into it forever. Go for it.
But also, if you've been dragged along here by your mum or dad, and you're not that keen on science yet, I didn't get into science till I was about 13. Until then, it was football. That was it. I was going to be a footballer. I think I was going to be a pop star. I had everything all mapped out. And then, around about the age of 13, I suddenly fell in love with physics. I did well on a class test, and I thought, oh, I'm quite good at this. I quite enjoy this. It's all about how the world works, and that's when I suddenly got the hook. So it's not something you necessarily have to be in love with from as far back as you can remember. Sometimes you just catch the bug at some point in your life. Okay, do we have time for one more question? Yes.
How would you make a crystal?
That's yours.
Oh, that's a great question. Well, the way you make crystals, you have to be patient, right? You have to have time, you have to be patient, you have to be slow. And what you do is you grow them. You grow them a little bit like plants. And the first thing you do is you get, for example, salt, or in this case, copper sulfate. And you put them into a pan or a jar or a beaker, and you warm them up. You warm them up until they're completely dissolved. And then you feed in as much as you possibly can. And then you take the jar and you let it cool very, very slowly. And the crystals will grow at the bottom of the jar to begin with, right? And that will give you a seed. Now, once you have this seed crystal, this first crystal, then what you can do is continue that process. You warm up and dissolve everything, and you hang your seed on a string, and it will slowly, steadily grow over the next few weeks and months. And this crystal of alum here, I don't know who grew it. You can see it's a beautiful octahedral crystal. And we know it's a crystal because you can see these nice flat faces, right? And they're very nice, consistent angles. This thing must have been grown over months and months and months. And I just love it. It's even got a little baby on the side with, again, the crystals at the same angle. It's an awful lot of fun to grow crystals, and you can make some really, really beautiful things of all kinds of interesting colors. Great project to do. I would strongly recommend you try growing crystals.
Right, well, I think we've run out of time. Thank you ever so much, ladies and gentlemen. Oh, did you have a...
I think we have
Yes.
one last little thing. And
Okay.
what we should do is, I think, do one final kind of alchemical trick, if you will. And what I'm going to do is I'm going to get my gas torch. and I'm going to light something. And I think, Jim, you might want to stand a bit back, just in case. We'll probably have the lights down in a second. And what we'd like you to do is to watch the action, because it's going to be really quite subtle. So if you could just, close my laptop. But anyway, we'll probably have the lights down. And wow, you're dicing with death down there. Anyway, okay. I only got my glasses on. Let's just see if we can get this baby lit. You gonna go?